Hello everyone, welcome to my channel. So today we are going to do Leetcode daily challenge, maximum difference between node and ancestor. As it is medium level question, so some tricks would be there even in the question, but we can solve it. Now here about the constraint. So the number of nodes in the tree are in range 2 to 5000 and the node value can go up to 10 to the power 5. So even we do different, so we won't be in a situation that we are required to take our variable type as long int. And here number of rows are 2 to 5000. So basically the time complexity can, and even this is a binary tree, right? So yeah, height of the tree, it can be a skew tree as well. Like here, not this is means if 3 was not there, then it can be like skew tree means 1 to 0, it is a skew tree. So yeah, we can go ahead with log n, not only log n, but yeah, at max it can go up to order of any solution. So now let us start this question. Let us read the description of the question and then see how it relates with the example which is given. So, given the root of a binary tree, find the maximum value v for which there exist different nodes a and b, where v is equal to a dot value minus b dot value, and a is an ancestor of b. Although they have mentioned that a is basically ancestor of b, and then they have given us the definition of ancestor and so on. But now the point is that this v value which is there with two different nodes a and b, we can easily figure out with any of the nodes which are there, because here they are showing us that a dot value minus b dot value and absolute of that, right? So in that context, if we take any two nodes, but the point should be that the difference which is there, that should be a maximum value. So to be precise, in this question we are required to figure out those two nodes, and here actually we are required to return the maximum difference, right? Not those two nodes. So we will be figuring out those two nodes. After difference of those two nodes, we get the maximum value of the difference. So that is which we are required to figure out. Means basically we are required to return the maximum difference which we can obtain in this whole tree. So that is the whole question here. And that is what they are doing all over here. So after explaining this question, now you can even solve by your own. So you can pause the video and solve this question by your own. And still if you have any difficulty, then you can resume this video and go ahead how I am coding the same. So now here in this example, if we see, like I'll be just explaining whatever is mentioned in this example. Here if we take this 8, right? And then if we take this 3, 8 minus 3, and if we go ahead with 8 minus 10, now it will go to minus 2, right? And if we go with 8 minus 14, then it will be again some minus, and 8 minus 13, that will be again some minus. But this is minus 2. This is, if we do 4, 5, 6, this would be minus 6, 13, 3, this would be minus 5, right? So the, even if we take just absolute, right? So this is the differences which we are getting. Then if we go ahead with 8 minus 3, right? So it would be 5, right? Then if we check for 8 minus 6, that would be 2. Like this only we are checking for each and every node which are there, right? Basically checking for all the possibilities which could be there. Means now not only 8, if we check between 3 and 6 and 1 and 4 and 7, right? And then we go ahead with 6 and 7 or 6 or 4. Like that we need to check for each and every node. So for this purpose what we can do is we can either go ahead with some, means basically we can go ahead with just doing DFS into the same and just checking each and every node, that at this point which is the maximum and which is the minimum, do the difference and store the possible maximum difference which could be there. So that is the thing which we are required to basically do in this question. And for that only we will be writing the code. So let me show you that how I have written the code. So here, this is the parent function which was given. So now here what we are checking, that if root equals to none pointer, then we will be directly returning 0. That simply means the maximum difference we can obtain is 0. Else what we will be doing, we'll be calling a new function, in that time passing the root, and then root value and again the root value itself, because here I will be checking for what is the current maximum at this point and what is the current minimum at this point. And this node is required to go ahead with the left subtree and the right subtree. So that's what I'm doing here. Now here, the first thing is that if node equals to null, means if not node simply refers to if node equals to null. So in that context, I will be returning whatever current max and whatever current minimum are there at that point. And this node equals to null simply refers to when it would be null. It would be simply null when we are at the leaf node. Leaf node, so it simply refers to that. Now the next node which are there, it it is not pressed, right? So it would be null. So when it reaches a leaf node, then when it goes ahead, right? So it will be figuring out that there is a null, and that point only it will be returning the current max and current minimum. And then this was the base condition for this recursive function. And now what is the main uh, recurrence relation in this particular? So basically these are the one how the first thing is that how we are figuring out with the current max is, we are just checking that whatever is being stored in current max and whatever is the node value, out of them what is the maximum that would be stored in current max, and whatever, if the present node value it is minimum, not only minimum, means minimum in the sense if it is less than basically this current min, then it will be stored in this current min. If it was maximum than the max, then it would be stored here. Although if both of these things are like same only, then surely at that point it would be zero. But that is the possibility only when previous values which are there, those were minimum or maximum as per that. That could be possibility like in, if you say that all the nodes are same and something like that. But here the point is that would be rare case. And then here we are storing whatever is in our left. So we are calling this particular helper function where we are going in the left subtree, having the current max and current min. And here in the right, we are storing whatever are there in our right subtree. And then at the end, what we are doing is we are returning whatever maximum left and right are there. So that is what we will be going ahead. Means at this point when we are reaching, so at this point there would be some maximum and minimum value, right? So out of that, whatever is the maximum or whatever is the difference between, because whenever we reach a leaf node in this particular subtree only, so at that point it will be returning this, right? And whenever we reach leaf node in this right subtree, then at that point again, if there is a leaf node, then it will be returning this difference. So whatever difference is being stored in left and right subtree, so out of them whatever would be maximum, that would be returned at this point. So that's why here we are returning maximum of left and right. So it would be returned to this parent function, and then we will be getting our final answer. So basically, as you can clearly see here, we are just doing DFS, or you can say recursive function, right? So the time complexity is order of n, and why it is order of n? Because here as we are doing that recursion, right? So internal stack could go at the maximum height of order of n, and according to that only, it is basically going in the depth of order of n only as per this stack. So if space complexity, if we consider that internal stack as well, then it becomes the space complexity of order of n. Else the space complexity here would be order of 1. And regarding time complexity, basically how much depth it is going and how many function calls are being there, in all those contexts it is order of n again. So so here basically the time complexity becomes order of n, and the space complexity here becomes order of 1. In that case, when we consider internal stack, when we don't consider internal stack, else it would be order of n. So this was all for this particular question. If you have any doubt, you could comment that down, and if you really like the explanation, you can like, subscribe and share my channel. So this was all. Thank you.